So, we have learned how to obtain measurements of a value which can take any number, and that comes from some kind of a measurement, some kind of a reading of an instrument, and we have learned how to obtain the reliable mean value of it, how to state it to an external audience in the form of a error bar. But there is another kind of measurement that a scientist often has to do. It is the measurement of a proportion. So, the measurement of a proportion. Of a proportion. Just consider the experiment that Mendel did, Gregor Mendel. He crossed two varieties of pea plants, one tall, another short, and it was found that there is nothing in between. So, tall or short, and he crossed these two varieties, and in the next generation he found that all the offspring are tall, and then they crossed within that generation, and he found that a proportion of that is tall and another proportion of that is short. So, his task then was to find out what proportion is tall. So, such kind of measurements are the measurements of a proportion. There are various situations where one can have this kind of proportion measurement problem. For example, in any evolutionary process, one encounters this kind of situation. For example, a very well documented process of evolution that happened before human eyes was a species of moth in England. The moth was originally whitish in color, and they sat on the bark of the trees which were also whitish in color. So, they could properly camouflage. The birds could not find the moths and eat them, and for millennia that was the stable situation. But with the advent of modern civilization, with the advent of atmospheric pollution, the bark started turning more and more darker. As a result, the insects, the moths became visible and they could be eaten by birds, and at that point it was found that over a very short period of time the whole species changed into a darker species, brown species, which could be again adapted to that particular color of the bark. Now, when that happened, essentially what happened was there was a mutation within the species which produced a colored offspring, and that colored variety was chosen by nature. It was natural selection which was selected by nature, and so in successive generation the colored ones, the brown variety of the moth, their proportion increased, and finally after some time there was no white ones left. So, that was a speciation event happening before our eyes. But if a scientist is studying that speciation event, then he will have to count or find out the proportion of the brown moths in each generation, and that will tell you how a speciation actually happens. So, it is a problem of measurement of a proportion. Similarly, in every field there are similar types of proportion measurement problem. If a beaker has two different types of microorganisms and you are trying to find out which one, or suppose one is a phytoplankton, the other is a zooplankton, one is a vegetative kind, plant kind, the other is an animal kind that eats on the plants, and as time progresses the proportion of the two will change, and that leads to the dynamics, and one has to study that by studying the proportions. So, there are various situations where one has to measure proportions. So, let us attack that problem, because that problem is slightly different from the measurement problem that we have encountered so far. So, we assume that there is some entity whose property we are measuring, but that can take only two values, either a tall pea plant or a short pea plant, nothing in between, tall or short. If we are trying to find out the proportion of the talls in the whole population, then if we find a tall one, we will say 1, or if we find a short plant, we will say 0. So, there are two possibilities, 1 or 0. Similarly, in the moth population, if there are two possible varieties, the white ones and the brown ones, then maybe the brown ones will be called 1 and the white ones are 0. The point that I am making is that in that kind of a proportion finding problem, one has the entity given as either 1 or 0, that kind of a situation. So, you will let us consider the situation of the moths, because it is better to work with an example to make things clearer. So, we are counting moths and trying to find out what is the proportion of the brown moths in the whole population. There are brown moths as well as white moths. What is the proportion of the brown moths? When we catch one and we see that it is brown or white, we assign a number 1 or 0 to it, and so let us call that measurement to be y. So, y let us call it y. Y is the result of one measurement. Now, that can be either 1 or 0. When would it be 1? When if the moth is brown, and 0 if the moth is white. There are two possibilities, 1 or 0. So, the y can get two values, two possible values, 1 or 0. Now, we ask and suppose in the population we assume that, say, in the population we assume in the population the proportion of brown moths is, say, 60% and white moths 40%. Suppose this is we are working with an example in mind. So, let us assume these values. In that case, in general, you will have there will be a probability of finding 1 and another probability of finding 0. So, P for 1 and 1 minus P for 0. In that situation, what will be the mean value of y? I have collected many, and then I have to divide by the total number of samples, and thereby we obtain the mean value. The mean value will be the mu, the mean value of y will be, we will do it by weighting the various possibilities. So, the one possible value is 1, weight it by its probability, plus another value is 0, weighted by its probability, that yields P. Therefore, the mean of y should be P. In this case, it would be 0.6. You would notice that 0.6 is not the value that y can take. it can either take 1 or 0, but the mean value can be a fractional number. Now, what will be the variance of this? Let us try to work out the variance. The variance can be obtained as a weighted, well, what is variance? The difference between the value that I get and the mean squared and its average. So, there are two possible values. So, we will simply do a weighted sum. So, weighted sum of the squares of the distance from the mean. Now, there are two possible values, 1 and 0. If it is, let me write sigma y mean variance, therefore, square is one possible value is 1 minus the mean value. This is the difference from the mean square, and I have to weight it by its probability. So, into 0.6 plus the other possible value is 0. So, 0 minus 0.6 square into its probability is 0.4. So, you see the total variance turns out to be it will be 0.24. So, notice the logic that there are only two possible values 1 and 0. If it is 1, then the distance from the mean is this much, its square, that has to be weighted by the probability of getting 1. Similarly, another possible value is 0, distance from it is this one, its square, and you have to weight it by the probability of getting 0, and thereby you get the variance. So, let us do it in general in terms of P. So, in general, let us do it here. In general, our sigma y square will be, this was P, this was P times 1 minus P square plus this was 1 minus P times P square. Okay. This is basically in terms of P is this. So, let us just work it out. P 1 plus P square minus twice P plus 1 minus P square is equal to P plus P cube minus twice P square plus P square minus P cube, and P cube cancels off, and we are left with P minus P square equal to P into. Okay, so that then is the variance of the observation, individual observation. The variance is this, and we get then the standard deviation sigma y is the square root of that, square root of P into 1 minus P. So, this is the result we get for a single observation. That means, I make an observation, I get a value, I make another observation, I get another value. If we go on doing that for a long time, then it will get a distribution, and that distribution will have a mean P and a standard deviation this. And this distribution is called the Bernoulli distribution. But you would notice that we actually do not make the measurement that way. How do we make the measurement? the way we actually make the measurement is that from the population we collect a number of moths, and then from that number of moths, say n, we find out how many are brown and how many are white. So, in general we do it a slightly different way. We get a sample, right. So, we get a sample. So, let me draw a line here, because now it will be a slightly different procedure. We take a sample. Say of 10 individuals. We take a sample of 10 individuals. Now, from that we will find out how many are the tall ones, how many are the brown ones. So, how many are ones and how many is are 0. And for each combination, each number, there will be a probability then. Can we find that probability? Let us try to work it out. So, the point is that we have assumed that the P, the probability of finding 1 in the population is 0.6 and probability of finding 0 in the population is 0.4. On that basis, we are proceeding. So, we are now taking 10 samples, and now we are asking what is the probability of, well, on an average 60% will be brown, on an average 40% will be white, and we have drawn 10 samples, and therefore, we would expect that 6 will be brown and 4 will be white. Will that really happen? No, not really. Not really, because of the we are ultimately doing a sampling out of a completely randomly mixed population, and therefore, there is no reason to have to expect that for every sample that we draw, it will reflect the population mean. That will not happen, but still we can calculate what is the probability of 6 ones out of 10 samples. How can I do that? Suppose we take a particular sequence. Suppose we have collected 10, and when we find out the first one, then it comes to be white. So, 0, second one is also white, third one is brown 1, and therefore, fourth one is brown, again white, brown, how many? 4. Suppose we have got it in this sequence. What is the probability of this sequence? That is rather easy to calculate, because what is the probability of getting 0? 0.4. What is the probability of getting 1? 0.6. Therefore, the probability will be, when I have already got the first one, it had a probability of 0.4. When I got the second one, what is the probability that second one will also be 0, that means white? It is 0.4 times 0.4. So, effectively by the law of multiplication of probabilities, the probability can be easily calculated as 0.4 first one times second one 0.4, because it is 0, times the next 3 are ones. So, 0.6 times 0.6 times 0.6 times this one is 0. So, times 0.4 times this was 0.6, 466. So, 0.4 times 0.6 times 0.6, and this is, it is easily seen that it does not really matter in which order the zeros and ones appeared. What really matters is how many times they appeared, and so we can write this as 0.6 appeared 6 times and 0.4 appeared 4 times. So, it is 0.0012. So, this is how these are calculated. But you would notice that I had initially set out the problem 6 ones out of 10 samples. This is not the only way you can have 6 ones out of 10 samples. It is possible that the first 6 are ones and then the last 4 are zeros, that is also another possibility. So, there are various possibilities, but notice that all these possibilities will have the same probability. So, all these possibilities or different possible ways of getting 6 ones and out of 10 samples, all of them will have the same probability. So, all we need to do is to find out how many ways we can have that 6 ones and multiply that by this number. And we know that the number of ways by which you can get 6 ones out of 10 samples is simply 10 choose 6. So, the probability of 6 ones out of 10 will then be 10 choose 6, this is how it is written, 10 6, and that has to be multiplied by this into 0.6 to the power 6 times 0.4 to the power 4. And this is we know how to write that. It is 10 factorial divided by 6 factorial times 10 minus 6 factorial times this number which you have calculated as 0.0012, and this comes out to be 0.2508. So, the lesson is that even though in the population the number of the proportion of the brown moths is 0.6, if I draw a sample of 10, the probability that I will find 6 of them to be brown is only 25%. It is rather small number. And we can similarly find out what is the probability of having say 7 ones and 3 zeros. So, similarly probability of 7 ones and 3 zeros will be, it is not difficult to calculate, that will be 10 choose 7 ones into 0.6 to the power 7 into 0.43, and that way we can calculate what is the probability of getting only 1 out of 10 samples, only 2 out of 10 samples, and so on and so forth, and we can plot a graph. And the graph here it is, well, it is possible to get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 samples we have drawn, and it is possible to get all of them white, it is possible to get all of them brown, it is possible to have all the intermediate ones, and you will find that it is the largest probability probably will have happen at 6, because the proportion of the moths in the population is around 60%, proportion of brown moths 60%. So, this will be smaller, this will be smaller, and this will be again smaller. So, you will get distribution. And if you now increase the number of samples, that n, if you now increase it, you will get more possibilities, and therefore, each possibility will have a probability assigned to it. And as you increase and increase this the number of samples, it will slowly become a smooth distribution. And it will tend to a normal distribution. It will tend to a normal distribution, and we will, the moment we claim that it will tend to a normal distribution, we immediately face the question, what will be the mean and what will be the standard deviation. We immediately face that question. We will take care of that. So, what I have driven at is that when we take samples from the population and find out the proportion within that sample, then the various possibility will have a distribution like this, and as you increase the number of samples, that distribution will tend to become a normal distribution. Okay. Now, this distribution of only the discrete ones is the Bernoulli is a binomial distribution, and as the number increases, it tends to the normal distribution. Now, we face the problem of finding out the mean and the standard deviation of that normal distribution.